Hello everyone. So welcome to this session of Cauchy's equation problems. So in the last session we have solved two problems, right? So we are going to continue with those problems only. So in this session we are going to solve two of the very important problems, okay? I'll mark it here. Very important. So this is the problem: x square d square y by dx square minus 4x dy by dx plus 6y equal to sine of 2 log x, okay? Yeah, so the first thing what we need to do is we need to do a few of the substitutions, right? X square d square y by dx square is written as d into d minus 1 into y. X dy by dx is written as dy. So here in the place of r of x we have log x, so we need to replace log x as z, right? Yeah, so now let's write the substituted terms, that is x square d square y by dx square is written as d into d minus 1 into y minus 4 dy plus 6y equal to sine of 2z, right? Yeah, so d square minus d minus 4d plus 6y equal to sine 2z, right? So this is d square minus d minus 4d is minus 5d plus 6 into y equal to sine of 2z. Yeah, so now for this we need to put d equal to m. We get it as m square minus 5m plus 6 equal to 0. Find the roots. The value of b here is minus 5, so it is minus of minus 5 plus 5. Minus 5 whole square is 25 minus 4 6 are 4 into 6 into 1 is 24 by 2. 5 plus or minus square root of 1 is 1, right? So we get m as 5 plus 1 by 2 or 5 minus 1 by 2, that is 6 by 2 or 4 by 2. 2 1s are 2 3s are 2 1s are 2 2s are, therefore the roots are 3 comma 2, right? So now for this write the complementary function c1 e to the power 3z, right? c2 e to the power 2z. So now find the particular integral yp. The formula is the r of x divided by f of d, where the value of r of x here is sine 2z divided by d square minus 5d plus 6, right? Yeah, so here again we need to replace d square by minus of a square, where the value of a here is 2, minus of 2 square equal to minus 4. So now yp would be looking like sine 2z divided by minus 4 minus 5d plus 6. So yp is sine 2z divided by minus 5d, and 6 minus 4 is 2 plus 2. So now the conjugates are minus 5d minus 2, right? Multiplied for numerator and denominator. So now we get yp is equal to multiply minus 5d into sine 2z minus 2 sine 2z divided by a plus b a minus b form again, minus 5d the whole square minus 2 square. Okay, so now solve. Yp would be equal to minus 5 into derivation of sine 2z, that is 2 cos 2z minus 2 sine 2z divided by 5d the whole square, that's equal to 25d square minus 4. So minus 5 into 2 is 10 cos minus 10 cos 2z minus 2 sine 2z divided by 25d square minus 4. So now our particular integral is minus 10 cos 2z divided by 25d square minus 4 minus 2 sine 2z divided by 25d square minus 4. So now again we need to replace d square by minus of a square. The value of a here is 2, so minus of 2 square is equal to minus 4, right? Minus 10 cos 2z divided by 25 into minus 4 minus 4 minus 2 sine 2z divided by 25 into minus 4 into minus 4. So now our particular integral is here, since we have minus, also our denominator when we simplify we get it minus, so this would be plus 10 cos 2z divided by 25 4s are 100, minus 100 minus 4 is minus 104. So here you are again plus minus, so minus 2 minus by minus is plus, so plus 2z and 2z divided by 104. So we can simplify this. 2 1s are 2 52s are, right? Yeah, again 2 5s are 2 52s are. So we get 5 cos 2z plus sine 2z divided by 52. So this is your particular integral. So now write y equal to yc plus yp. We get y as yc, we got it as c1 e to the power 3z plus c2 e to the power 2z. Yp we got it as 5 cos 2z plus sine 2z by 52, right? Yeah, so this is your y. So now we need to replace z is equal to log x, also e power z is equal to x. So our final general solution will be looking like c1 e to the power 3 log x plus c2 e to the power 2 log x plus 5 cos 2 log x plus sine 2 log x, right, upon 52. Okay, so now we can do few substitutions here. So here we can write it as 3 log x corresponds to log x whole cube and 2 log x corresponds to log x square, right? So after substituting that we can cancel e and log, so our left out terms are x cube and x square. So we can write it as c1 into x cube plus c2 into x square plus 5 cos 2 log x plus sine of 2 log x divided by 52. So this is your general solution. Okay, yeah. So we have one more problem, so we'll solve that and we'll wind up this session. So this is your next very important question. Okay, so please make a note of this and please listen to it very carefully. Okay, because these Cauchy's equations are very important. I guess 2 problems might come from this concept. Okay, from this Cauchy's equation in the whole question paper of module 4. Okay, yeah. So now here in place of r of x, in r of x we have the x terms. Till now we had log x, right? So now here we need to write x equal to e power z. Okay, so now let's simplify for this 10x divided by 1 plus x first. Okay, let's see what we'll get. 10 into wherever x is there, replace it by e power z plus 1 by e power z. So this would be 10 into e power z plus, if we bring this 1 by e power z, we can even write it as e power minus z. Okay, yeah. So our this left hand side would be looking, right hand side would be looking like this. So again now we need to substitute few of the terms, right? So I'll write it directly. So this we can write x cube d cube by dx cube, we can write it as d into d minus 1 into d minus 2 y, right? plus 2 into d minus 1 y, right, plus 2y is equal to this term 10 into e power z plus e power minus z. Okay, yeah, so now we'll solve for this. D into, again d is multiply d into d square minus 2d minus d, again minus 3d, minus 1 into minus 2 is plus 2 plus 2 into d square minus d into y plus 2y is equal to 10 e power z e power minus z. Okay, so now multiply this d to the whole term, that is d cube minus 3d square plus 2d, again this plus 2d square minus 2d plus 2 into y equal to 10 e power z plus e power minus z, right? So here we can cancel few terms, that is plus 2d minus 2d gets cancelled, so the remaining terms are d cube minus 3d square plus 2d square equal to minus d square plus 2 into y equal to 10 e power z plus, I am multiplying 10 again, 10 e power minus z. So this is your required term. So now for this we need to put d equal to m, right? So that we get m cube minus m square, m term is missing, plus 0m plus 2 equal to 0. So this is again of the cubic form. Write the coefficients 1, minus 1, 0 and 2 and find the first root, that is the root is, the question we need to write is x cube minus x square plus 2, right? Press the calc button, first put it as 0, plus 1, minus 1, yeah, see, for minus 1 we got it as 0, so our first root is equal to minus 1. Minus 1 into 1 is minus 1, minus 1 plus minus 1 is, that is minus 2, minus 1 minus 2 is plus 2, 0 plus 2 is 2, minus 1 2 is a minus 2, we get it as 0. So the term is m square minus 2m plus 2 equal to 0. So now I will solve this here. So value of b is minus 2, so 2 plus or minus square root of 2 square is 4, minus 4 2 is 8 by 2, 2 plus or minus square root of 4 minus 8 is minus 4 by 2, square root of 4i square, since there is minus term, 2 plus or minus square root of 4 is 2i by 2, so here we can take 2 common, 1 plus or minus I by 2, so therefore our root we get is 1 plus or minus I, okay, along with minus 1. So our yc term would be looking like c1 e to the power minus z, we have minus 1, right? I'll write that first, plus c2 cos, the value of beta is 1, so c2 cos z, plus c3 sin z into e power alpha is again 1, e power z. So this is your complementary function. So similarly find the particular integral. The value of f of d is d cube minus d square plus 2 into the r of z is 10 e power z plus 10 e power minus z. So again we have two terms for yp, so solve it for yp1 and yp2. First term is 10 e power z divided by d cube minus d square plus 2. Again this is of the form of e power ax, right, the first type. For that we need to replace d by a, the value of a equal to 1. So our yp1 would be looking like 10 e power z divided by 1 cube minus 1 square plus 2, that is 10 e power z divided by 1 cube, 1 square is 1, 1 minus 1 0, and we have left is only 2. 2 ones are 2 5s are, so yp1 we get it as 5 e power z. Okay, so now similarly find for yp2. So the second term for yp2 is 10 e power minus z divided by d cube minus d square plus 2, where the value of a here now is minus 1. So 10 e power minus z equal to minus 1 cube minus of minus 1 square plus 2, that is equal to 10 e power minus z divided by minus 1 whole cube is equal to minus 1, minus 1 square is plus 1 plus 2. So you get 10 e power minus z divided by minus 2 and plus 2 is 0. Okay, yeah, so you got here 0. So now we need to take f dash of d. The given f of d is d cube minus d square plus 2. F dash of d we get it as 3d square minus 2d. Okay, yeah, so now yp2 equal to, so now we need to multiply z. Okay, since the parameter here is z, right? So we get 10z into e power minus z divided by 3d square minus 2d. Again the value of a here is minus 1, so 10z e power minus z divided by 3 into minus 1 square minus 2 into minus 1, 10z e power minus z, minus 1 square is plus 1, so 3 plus 2, we get 10z e power minus z equal to 5. 5 ones are 5 2s are, so our yp2 we get it as 2z e power minus z. Okay, so now we have found yp1 and yp2. So now we can write yp equal to, yp1 is 5 e power z plus yp2 is 2z e power minus z. So now we can write y is equal to yc plus yp. So we get y as, so we got yc equal to c1 e to the power minus z plus c2 cos z, c3 sin z into e power z, right? Plus yp we got it as 5 e power z plus 2z e power minus z. So now replace e power z equal to x and z equal to log x. Okay, so now our final general solution will be looking like c1 e to the power minus log x plus c2 cos of log x, c3 sin of log x into e to the power log x plus 5x, right? We have e power z plus 2 log x by, we have e to the power minus z, so we can write in the denominator 1 by e to the power z. Okay, so here we can cancel exponential and log, so we are left out with c1 by, so if you take this we get log of x into inverse, if we take this minus up, so we can cancel exponential and log, we are left with x inverse, right? So we can write it as c1 by x, it is equal, it's actually c1 x inverse, I have written it as 1 by x. Okay, c1 by x plus c2 cos log x plus c3 sin log x into x plus 5x plus 2 log x by x. This is your general solution for this question. Okay, yeah, so that's all for this session. We have solved two very important problems. Okay, from these two any one of the problems might come with the values changed. Okay, so yeah, that's all for this session. We have left with one more concept that we will cover it in the next session. Thank you.